Welcome back. So in this lecture we are going to study the dynamic force analysis of reciprocating engine. As we studied in the last lecture, we talked about the piston effort, and in this lecture we'll talk about the force acting along the connecting rod, and then we'll talk about the crank effort, and finally we'll talk about the torque on the crankshaft and thrust on the bearing. So in the last class we discussed the piston effort is the forces applied by the gases minus inertia force minus frictional force and plus minus mg. So, and this is the expression for piston effort, and this force is acting along the line of stroke. Now we want to find out the force acting along the connecting rod. So let's say this is the FP piston effort, and this is exerting a force in the connecting rod. Let's say that force is FQ, right? So this FP, this is FP force, and this is Fn volt thrust. So if we find out the FQ cos phi, so this is the force acting on the connecting rod. So from here we can say FQ cos phi is equal to Fp. So Fp is known to us, so FQ can be find out Fp over cos phi. So this is the force acting along the connecting rod. And secondly, the volt thrust, which is denoted by Fn, can be find out Fq sin phi, which is equal to Fn. So Fn is equal to Fq sin phi, and here cos phi, as we know, that is given by square root of 1 minus sine square theta over n square, because as we discussed in the last lecture, L sin phi is equal to R sin theta, and from here we can find out sin phi is equal to sin theta over L by R, and which is sin theta over n. So cos phi can be written as 1 minus sine square theta over n square. At the place of sine square phi we write sine square theta over n square, square root of complete. And so this Fq is given as Fp piston effort over square root of 1 minus sine square theta over n square. So this is the force acting along the connecting rod. Now as we find out the thrust on the sides of the cylinder wall or normal reaction on the guide bars, so here we want to find out the thrust on the cylinder walls, so which is equal to Fn, and Fn, as we find out, which is given by Fq sin phi, and Fq is, already we find out, Fq is Fp over cos phi multiplied by sin phi, so this becomes Fp tan phi. Here phi can be replaced in the form of theta, because theta is our input parameter which is known to us, so this phi can be replaced in the form of theta. So the thrust on the sides of cylinder is given by Fp tan phi. Here we also can consider the WR. So if we draw the free body diagram of the piston, then this is Fp and this is Fq. Fq is the force applied by connecting rod on the piston, and we know that this angle is phi. And now if we resolve this phi Fq, now if we resolve this Fq in two parts, then this part is Fq cos phi and this part would be Fq sin phi, and there is a mg force, and the reaction force, so normal reaction would be in this direction, and that would be Fn. So if we consider mg also, then Fn would be equal to Fq sin phi plus mg, and as we know that Fq is Fp over cos phi multiplied by sine phi plus mg, and this becomes Fp tan phi plus mg, which is wall thrust or normal reaction on the guide bars or cylinder liner. So this is how we can consider the effect of gravitational force also on the piston. And now if we complete the free body diagram of the engine, then we can say this is piston and this is acted upon by Fp, Fq, and this is connecting rod. So here this is Fq, this is Fq, and this is our crank, and there is one force which is equal to Fq, and this is crankshaft. So now this is the complete free body diagram of crank, connecting rod and piston, and here this is Fn and this is mg. So now we know the force on the in the connecting rod. We now at this time we know the forces on the piston. So next we'll find out the force on the crank. So this is the force. We'll understand this diagram. This is the force acting on the crank, right? This is Fq. Okay, so this Fq, if this angle is phi and this angle is theta, then we know that this angle would be theta plus phi, and this Fq can be resolved into two parts. One is tangential part, tangential or perpendicular to the crank, and one is along the crank. So along the crank is part which is Fp, which is given by, along the crank the force is given by Fb, right? So that would be the cos component of this Fq, and the tangential part, that would be the sine component of Fq. So one perpendicular to the crank is known as crank effort, and along the crank which is known as thrust on the crankshaft bearings. Here the component of Fq of this force perpendicular to the crank is known as crank pin effort and denoted by Ft in this figure, and the component of Fq along the crank produces a thrust on the crankshaft bearings, and it is denoted by Fb, which is this force. So resolving the Fq perpendicular to the crank, so Ft is given as, so this angle is theta plus phi, so Ft is Fq sine theta plus phi, and Fb is given as Fq cos theta plus phi. So here Ft is Fq sine theta plus phi, and Fq, as we know that this is Fp piston effort or cos phi multiplied by sine theta plus phi. So this is the crank pin effort, and resolving the Fq along the crank, this will give us a Fq cos theta plus phi. So this becomes again Fq is Fp or cos phi, and this is cos theta plus phi. So this force will create a reaction on the, or thrust on the, this will create a thrust on the crankshaft bearings, and this will produce a torque on the crankshaft, and that torque would be Ft multiplied by R. So let's see. So the crank effort or turning moment or torque on the crankshaft is given by Ft multiplied by perpendicular distance of Ft from the crankshaft, and this perpendicular distance is R, right? So we can write, so the product of crank pin effort Ft and the crank pin radius R is known as crank effort or turning moment or moment on the crankshaft, which is given by T and Ft multiplied by R, and Ft already we know that the Fp sine theta plus phi or cos phi multiplied by r, and again the cos phi can be written as 1 minus sine square theta over n square square root. So this is how we can find out the torque which is taken as output on the crankshaft and which is known as crank effort or turning moment or torque on the crankshaft. So thank you. In the next lecture we are going to discuss the inertia force of connecting rod, and we'll talk how we can consider the inertia force of the connecting rod. Till now we considered the inertia force of the piston only, and in the next lecture we'll discuss what is the way to consider the inertia force of the connecting rod. So thank you.